Okay, another article that you wrote recently, which I thought was excellent and really just a fascinating line of evidence for creation, in my opinion. And so right here, Dr. Bergman, July 10th, ape and human Y chromosomes compared. So in my study, without going through the details of the article, and maybe you can speak to this, the human and ape Y chromosomes are divergent in many ways, the human and chimpanzee Y. And just from my own slides here, I have a visual of your Y chromosomes from the primates, because the evolutionary community considers humans to be human apes, and then your chimpanzees, bonobos, so on and so forth, to be non-human apes. When you actually compare the Y chromosome with, let's say, the chimpanzee Y, they're nothing alike. They're only about 35% the same when you consider overall size differences, overall architecture, and gene content. It's half the size, as you can see here. And in terms of the nested hierarchy they like to point to, right, Jerry? The gorilla Y and the human Y are more similar to each other than either are to the chimpanzee Y. And so there's a break in their so-called hierarchy. Anyways, I was wondering if you could speak a little bit to your work here and this topic of ape and human Y chromosomes being compared.
Well, one thing that bothers me, which I pointed out in the article, was that what they're trying to do is they'll do a sequence, another sequence, and they compare the two. And they look at this sequence evolved into this sequence. Now, the problem with that is, of course, we don't have any sequences of our missing link between us and the apes. So they take modern apes and modern humans, and they assume that the ape genome was similar 50,000, 100, 200,000 years ago. And the human, therefore, evolved from this ape genome. And the problem with that is, of course, is they're comparing modern to modern and not actual ancient to modern. And that's one problem. The other problem is what we need to focus on, I think, is why are there differences? Not how one became another, but why the original in the ape, for example, is different, what function it has, and why the Y in us, for example, is different and the function it has. And of course, one major obvious difference is that is the sexual dimorphism between humans is much greater than that between apes. Male and female ape are similar. You can tell the difference if you studied anatomy, but by and large, the human differences, when you go through adolescence, pretty obvious that this person's a male and this person's a female. I know sometimes it's not as obvious, but generally it's quite obvious the differences between males and females, quite outstanding. In fact, when you look at this transsexual revolution in this country, the surgery to make a man into a woman involved shaving the Adam's apple, because that's a sexual difference, a secondary sexual trait, because men have a more prominent Adam's apple than women do. So if you want to transition to a woman, there's about 35 operations that can be done to cause that transition to occur. And one of them is shaving the Adam's apple down. So that's a secondary sexual trait. And so when you look at chromosomal differences between males and females, especially the X and the Y, or the X in particular, then we can see that a lot of those differences have to do with the male secondary sexual trait differences, which causes the animals to be dimorphic. Dimorphism, of course, for most animals, there's differences, but not nearly as great in most cases as people. We have a huge dimorphism between male and females in humans, but in cats is the most famous example, when the vet makes a mistake. Oh, sorry, I thought this was a female, but it's a male. And I always find that humorous. You're a vet, you're supposed to be able to tell the difference. But I'm understanding from friends that had their cat checked by the vet, vets not uncommonly make mistakes. And I say, come on, you should figure that out. And he said, well, when they're really young, it's not that easy to figure out. When they get older, it sometimes is a lot easier. But on the other hand, with some animals, of course, dogs is more apparent. But on the other hand, most physical traits of a dog are pretty identical to males and females. But certainly with humans, that's not the case.
I think you made a lot of excellent points there. And so what we're looking at would be better explained as functional or design differences rather than evolutionary differences from a common ancestor.
Evolution leads them away, I think, from what the main purpose should be of understanding the genome. Let's try to figure out what it does and why there are differences, not trying to hypothesize how the differences occurred through evolution.
Right, I think you nailed it, because this visual here, Jerry, this comes from an evolutionary publication in 2017. And notice how they assume evolution to prove evolution. So they got human and chimpanzees here. So chimpanzees are our supposed closest cousin. And we go back to an apparent ancestor 6 million years ago here. And then there was a split, human line one way, chimpanzee and bonobo lineages the other way. But they're assuming that this common ancestor 6 million years ago actually existed, but we don't have the genetics or the data or the evidence of this ancestor. Is that right, Dr. Bergman?
Oh, yeah, that's right. And that is an interesting area to look at, which I haven't done so recently. So I'm glad you brought that up. If that comes up in the literature, I'd like to do some comparisons between the human Y and the chimp and other Y. And I expect there would be a huge difference because, of course, humans are very sexually dimorphic, not nearly as much as many animals are, or
Well,
much more so than many animals.
Yeah, it's interesting because in this publication, they say that the Y chromosomes between the human and chimpanzee differ enormously. So it's not just a moderate difference, but it's an enormous difference in size and gene content. They say the chimpanzee Y is only half the size as the human Y. And in terms of shared genes and overall architecture, the human Y is more similar to the gorilla Y than to the chimpanzee Y. And so as a creationist, we can view this without that evolutionary lens or bias and say, yeah, they're so different because they're not related. We're looking at separate ancestries. But the evolutionists, correct me if I'm wrong, Jerry, they're assuming evolution. So now they're just going to explain, and you talk about this in your paper, they're just going to have to say, well, after the human and chimpanzee lineages split, these deletions happened over here, this duplication happened over here. So aren't they assuming erroneously that these mutations even happened in the first place to make these differences?
And clearly, they assume evolution is true and try to explain the world, in this case, the genetics world based on evolution. And boy, that gets one into trouble. I've learned you got to be careful about assuming things because assumptions can get you into big trouble. And so in your life, I'm sure if you think about your past 20, 30 years, assumptions got you into trouble because you assumed something which turned out not to be true. And so in the case of evolution, they all too often assume things which all too often turns out to be not true. And so stop assuming, just look at the genes and try to find out why they are different. Don't assume, try to figure out why they're different. And with apes and humans, of course, we know major reason is that humans are among the most dimorphic of all animals, all sexual animals. Most animals, I would say the majority of animals, you can't tell the difference between males and females. You know, if you're an expert, you can. Size is big, colors, so there are differences. But on the other hand, without knowing a lot about birds, for example, I can't tell whether or not a bird coming up to my feeder is a male or female. I can't tell. Now, if I was an expert, I could, but there's not obvious differences where with people, it's pretty obvious. Even if you're a 3-year-old, you can tell the difference between a male and a female because the differences are so great. Right. 3-year-olds know very well, very early, who's mommy and who's daddy and the differences.
So what would be your favorite way or preferred way in terms of baraminology? Because we as creationists, we believe in separate ancestry. We would argue that humans are not related to any other form of life. We could group humans together with Neanderthals, Homo erectus, so on and so forth. We've done shows on that in the past, Jerry. But that group, the human group or humankind, are separate and independent from, let's say, the chimpanzees, gorillas, dogs, fish, banana plants, and so on and so forth. Where the evolutionists, they argue for universal common ancestry. All life is related through common ancestry. And so what's the best way, or what's a way that we as creationists can determine that boundary where we say this creature is unrelated to these creatures over here?
I think one of the best illustrations, if you look at the human phylogeny tree, we all were at one time, well, the most ancient common ancestor of all life is sponges.
Right.
And so later on, though, we got worms. And so in the human evolutionary tree, you got at the bottom, you got a worm, and that worm eventually evolved into people. Well, another worm is still a worm. It's not evolved at all. Another worm is interesting. I did an article on this. Another worm is, ironically, has evolved human type eyes, but that's about all. Looks very strange creature, but nonetheless, this worm evolved human camera type eye. This worm didn't evolve at all. And this worm evolved into people. So if you line it up that way, you can see I think, a big problem in evolution, and that why did this worm continue to stay a worm? Why not? Evolutionists can explain that. Well, it was highly evolved, and therefore it well adapted to its environment, and therefore it didn't need to change. And so therefore, no problem. But on the other hand, why did this worm evolve into people? Well, its environment was not well adapted, and so therefore it evolved to better adapt to its environment. But in many ways, the environments are the same. It's hard to say this environment caused this worm to evolve eventually into people. This environment caused this worm not to evolve at all. And another environment caused this worm to evolve camera type eyes, which look very weird, but they work pretty well, I guess, from the research.
That's an excellent answer. I just finished a 3-part series with Dr. Carl Werner on his work on living fossils. And he pointed out that there are many species of mammals existing with the dinosaurs, but textbooks and kids' books don't like to show that. Many living fossils all throughout the rock strata that haven't changed at all in millions and millions of years. And so I think you nailed it there. Why didn't this specific organism evolve into anything else? But then this organism in the same amount of time evolved from a small primate-like creature into humans. I mean, those are some major changes, and we all live in very similar environments. And so why is one organism changing so drastically in terms of phenotype, and then another one is not changing at all, if evolution is true?
That's true. It's a good point.
That's some great points you're making.